Right, put this generator on the end. Finally got round to doing it. There's the bridge for it. Just filling the capacitor again. Right, a couple of questions regarding why I bothered even switching the motors. Why not just have them running flat out all the time? Well, when they're running flat out all the time, obviously they're using more current, and more current we don't want to be running all the time. We only want to be running the amount of current required to keep the thing running. Hence the reason why I can switch barrel 1, barrel 2, barrel 3, barrel 4. Barrel 1 is the primary, so that's that one. This and that will produce electricity by running one barrel. No problem at all, the speed's good. As soon as you try putting a load on it, then the whole thing starts to slow down to the point where it nearly stops. So I can switch another one on, so that brings the speed back up. If it's still not enough, I've got 2 extra barrels to keep switching on. So that's just basically what it's for, so I can provide more torque for more current being used by any of the generators at one time. So I hope that explains that a little bit. This generator here goes into that bridge rectifier that just fills that capacitor. What I'm hoping to do with that, use that voltage and put into here to drive the 4 motors. That's the aim. This one is just to prove over unity in the event that that one actually works. This one will have just a little LED on it just to prove that it's producing electricity. I don't want to even have the power supply on to start it. That's the whole point. Switch the power supply off, and I'm going to spin this by hand, and you can see the voltage start to rise. That will obviously do the same. That should be enough with no load on just to start the thing firing on one pot. Once the motor has come to some kind of speed, I can then switch another pot on, and as it comes up again, and eventually I can get to full power without actually having no input. Yeah, I know it probably never work, but that's where I'm going with it. People have asked, and that's what I'm attempting to do. As soon as I try dropping a load on this by making it run this, the whole thing comes to a standstill, and I have to start switching more motors on, more pots on if you like, to give it more torque to keep the speed up, to keep the voltage up, and the current of course. So at the moment everything, although appears to be doing what it's supposed to be doing, the whole thing's failing, as one would expect. But I'm not anywhere near over unity or even breaking unity at the moment. But we'll still keep working on it. From that generator goes into that capacitor. It comes out here. That's the voltage readings. Those cables go out to run that one there. That collects the back EMF. That one comes out to the actual 3-phase generator, which is the same as that one. Doesn't go anywhere, do anything, it just sits there in that capacitor, same with that one. Now the whole thing's going to be running on 12 volts, not 24. So as we can see with the meter, nothing's charging. Switch the first motor on. I've actually just disconnected that. See it coming up to speed. We've only got one firing, which is that cylinder there. You can see the voltage coming up from that generator. It's drawing a heck of a lot of current, I know. Learn to come up to speed. Now she's up to speed. We're going to try starting this one by plugging this in to there. Now watch what happens to this motor. Running very strong. Almost stalls it, so I need to switch another motor on to pull it back. In fact, we'll switch all 4 on to get her back up to speed. That motor is now starting to go on its own. being driven by that. All 4 motors pulsing. 72 volts out of there. I'll explain why I'm doing all things in this. We're dragging the maximum amount of power supply we can. As you can see, the voltage has dropped down. This one is struggling a little bit to get up to speed, but it is doing. Now if I just run it on 2, now we've got a full load on. We'll just take the load off. The sensor flies up. Drop the load on. And that pulls it down. Now if I was running this Newman on 1 motor, as you can tell, on a load that thing would just come to a complete standstill. Hence the reason for the 4 switchable motors. Depending on what load I've got on at a particular time, depending on how many barrels I switch on. So basically it's just a test bed. So we'll just switch all those off, and you can actually see that's coming up to nearly 90 volts now. Right, bring the whole thing to a standstill. Been asked several times of my building methods, how I put them together and what machines we use. Right, as we start, I start with the drawing. I just print it off the computer. So I use a CAD program, I suppose. I actually use CorelDRAW. Cut it out. We stick that to a piece of timber. We will then coping it out, if you like, on that, and then we use the pillar drill to actually drill the holes for the magnets to go in. This is before we put all these bobbins in. We'd stick the picture off the computer to that. We'd clamp both the boards together, drill the holes with a pilot all the way through, so they end up with a board marked out, and saves putting 2 transfers on. And as I said, then we drill them out and go from there. And that's basically how everything's built in this little workshop of mine. That's the rotor all set up with all the magnets in. As you can see, north, south, north, south, north, south. All the bobbins on the plate with all the connections ready. This is salvaged from the one that I've got on YouTube that went bang. This is what I'm testing it up for. Not the same magnets as I was intending to use. I've actually used those in another one. So these are still neodymium magnets, very powerful, but only about 3.5mm thick, these ones. So I may not get the same results. There we go, we'll start assembling it back up now. Flywheel fitted to the shaft. I was going to build this out of an aluminium one to get some weight, but to be honest with you, I wasn't that impressed with the output of this. I'm only really doing this as an exercise to say, well, I finished it, done all the tests, and then I can start dismantling.